I wanted to do a video today on something that's not a review, it's more of an educational thing, something that I experienced. I was taking, basic story, real short. I was taking some classes for a medical degree, associate's degree for medical, and I was forced to take a computer class. So the computer class let's just put it this way, it was clearly a way for the college to make money, a little bit of additional money, and it was mostly focused on Microsoft Office. However, it had a little bit in the beginning, how a computer works, what parts are needed, and it got into binary. What bothered me was the way they tried to teach people to convert binary was the most ridiculous thing I've ever seen. I even tried to see if the instructor would let me show how I did it, and she said no. So they were clearly trying to teach based on a school's curriculum. Maybe it was a state governed thing. Who knows these days? But I wanted to make this video because it's really easy. It shouldn't be difficult. I mean, they were trying to use exponents and all kinds. I mean, it got ridiculous. So figured I'd go over this real quick, and it's not going to be a long video, hopefully, but it should show you how it's done and done in a very easy way. So let's take a number. We'll take a number 107. And this too, by the way, in the computer class, now if you're taking computer science or something like that, it's probably going to get a little bit more in depth. However, with this class, again, it was a basic computer class. They only went to 8 bits. That's all you really need, because if you can do 8 bits, you can do unlimited. I mean, it's all the same. So, all right, so we'll use 107, and I'm just going to put a little border around this and make it pretty and all that good stuff. This will just kind of help everybody see what we're working with. And I'm just going to color this. It's going to be a nice pretty orange. All right, so 107 is what we're going to deal with right here. Make this a little bit bigger. Okay. We will put the binary number here once we have it. And I'm going to show you how easy that is to get, because it's a very simple process. It's nothing that you need to worry yourself on. The way binary works is you've got a 1 byte, which is 8 bits. So first is an IP address, 192.168. Yada yada. Each one of those numbers in between the dots is an octet, is 8 bits. And that's what this is going to represent. So 107 could be the first number in an IP address. Just throwing it out there. In a binary number, something like, you have 1, 0, 1, 1, 0, 1, 1. Let's just say, just pulling a number out of my butt here. Each one of these numbers here is a position. The 1 and the 0 are the indicators. It's either on or off. 1 is on, 0 is off. And it's on or off for that position, that value. And we're going to get into that in just a second here. How about that? So 8 bits, we're going to have 8 positions. And in binary, each one basically doubles, or is multiplied by 2. So first position is 1, 2, 4, 8, 16, 32, 64, 128. These are the values that will be represented by the 8 bits. And again, this is something that it continues on. So, you'd be 256, 512, 1024, yeah, and it can go on forever. But if you can get this, you can get anything. You could do 16 bits, you can do 100 bits, so whatever you need. So again, let's just format these so everybody can kind of, want to make it easy to see, understand, and you'll know where we're at with this. 107, we're going to convert it into binary, and then we're going to convert it from binary back into decimal. So we've got these columns. Let me just draw one more thing. We'll make the columns a little bit more evident here, so everybody can follow along. All right. The easiest way to do this is, these are your values. This is your numbers. So the first number, we're working with the whole number 107. What is the highest number that you can get to without going over? Well, you can't get to 128. 64 would be the highest number you can get to without going over 107. So you're going to put a 1 in that column. Okay. Now down here, what we have to do is we have to take that 107, and we use 64 of it, so we have to subtract 64, and that's going to equal 43. Okay. So 43 is now our new number that we're working with. And just to make that a little bit clearer, we're going to color that orange. All right, so now we'll do the same thing. What's the highest you can get to without going over 43? Well, the highest you can get to is 32. So we're going to put another 1 in that column. Okay. And then we're going to do the same thing. So we had 43, and we're going to subtract 32, and we're going to come up with 11, right? So, and again, I'll color that orange just so we know that the orange is always the number that we're working with. So again, same thing over again. What's the highest we can get to in values without going over 11? Well, we can't go to 16, so the highest we can get to is 8. So we're going to put a 1 in that column. Now, these don't have anything in them. Don't worry about that. We're going to get to that in a second. So we're going to do the same thing. 11, we used 8 right here, equals 3. And by all means, if you're allowed to on your test or whatever class you're in, and it might sound stupid, use a calculator. I mean, we're all human, and we can make simple, the easiest mistakes. If you make a mistake, and more so in the next step, converting from binary back, but if you make even on a calculator, if you fat finger on a calculator and you mean to hit an 8 and you hit a 9 and you don't notice it, you're going to be wrong. So, always just double check the work, always pay attention, obviously, to what you're doing, and just, just be mindful. So back to here. So now we're down to 3. So the highest we can go with 3 is to the 2. So we're going to put a 1 there. And now, of course, we're down to 3 minus 2 equals 1. Okay, now, okay, you might not need a calculator for that, but, hey. So 1, the highest you can get to is 1. That's it. All right. Now, what I'm going to do is we're going to draw a nice little line here, a nice fat line for the bottom. I don't know why I did that, but kind of screwed up this. This is just FYI if anybody wants to know. This is Open Office is what I'm using, and Open Office is it's a free version of Microsoft Office. It's got the puppy heard something. It's got Word, Excel, all the usual Microsoft Office things. It's free. They integrate back and forth very well. For instance, their document, which would be Word, you can save it in its own format, but you can also save it in a .doc for Word, and you can send it to people. They can open it up in Word. They can send you something in Word, and it works great. All right, so back to this. So we're now going to convert this. We did the work. Now we're just going to convert this into binary. So first column is a 1. Second column is a 1. Fourth column, there's nothing in it, right? Well, if that column isn't turned on with a 1, it's a 0. 8 is a 1. 16, again, nothing in it, so that's a 0. 32 is a 1. 64 is a 1. And do not forget that last column. Even though there's nothing in it, you still need that last column there as a 0. So here's your binary number. So you can write that as your answer. So you've got 110101110. So there is your answer to 107. 107 as a decimal is 1101010 as a binary number. So that would be your answer. We'll make that pretty green, bold it so you can see. All right, that's the easiest way to go from decimal to binary. All right, so now we're going to go the other way. So let's say they give you on a test this number, and they want you to convert this back to a decimal number, and you don't have the one, so you don't know what it is. Well, the easiest thing to do is if you can write on a test, or if you've got scrap paper or whatever, draw this chart out. Put this out there. And then this way, you can actually visualize what you're doing. So if we do that, and we create another, let's just create another little grid here. Actually, you know what? Let's just delete this. We'll delete everything here, and we'll pretend like we're just starting from scratch. So they gave you this number now, and we're going to convert it back to a decimal form. So you're going to want to put in your numbers, your values, I should say, not your numbers. These are always going to be the values. The numbers or the on and offs are what we're going to put in. 128. Okay. So we're going to now put this in. So you've got 1, 1, 0, 1, 0, 1, 1, 0, right? So that's what you've got for the decimal number. And you could even really kind of get rid of all this. It's fine. Let's just delete all that. All right. Now this is where I was saying, if you can use a calculator, use it. Some classes I know, you may not be allowed to have a calculator or whatever. But this is the easiest way to do this. And again, we're all human, so you could possibly make a mistake in your head. That's why I'm saying use the calculator if you can. So what we're going to do is everywhere that you have a 1 and that value is turned on, you're going to add them together. So we've got a 1 in this column, which is a 1. We've got a 1 in this column, which is 2. There's a 0 in this one. So the 4 value is turned off, so we don't need that. Next one is the 8 column, so we're going to add that in there. The 16 column is turned off. The 32 is turned on, and the 64 is turned on. The 128 is turned off. So these are the values that we're working with. Okay. So again, you'd want to add these together. Oops, sorry. If you can use a calculator, use a calculator. And even using a calculator, again, be careful. Like I said, you could go to hit the 8 and fat finger hit a 5 or hit a 9. Or, even if you hit a 9, that's going to throw you off by 1 to your final answer. You would get 108, and on your test, that would be wrong. So you're basically going to take these values that all had the 1 in them, and you're just going to add them up. And just simple math, and you're going to come up with 107. So you've got 3, 11, 43, 43 and 64 is 107. So again, you've got your answer. And this is also a good way when you do get your binary number, if you want to double check it and just like simple math class back in elementary school, check your math. You add something up, can you subtract it and get the same answer, or vice versa. So that's going both ways. Now, one other thing that I saw in my class, and I can't say that they were trying to trick us. It was something that they did that was a little bit off. Again, it wasn't a trick question. It was something that was I guess I just wanted to see if you knew what you were doing, and you could implement it to where it needed to be done. So they basically said, what happens, and we're going to clear this out. What happens if you had all ones? What is the highest decimal number that you could have with all 8 bits being 1? Okay, well, you already know how to convert that back, right? Oops, let's fix this. We'll change the font to a 14, and we'll center it, and all that pretty stuff. So you can do this a couple ways. I'm going to show you the harder way, not impossible, it's not difficult, but the harder way, and I'm going to show you the easy way. Notice there's an extra one here that's going to come up. It's going to come into play. So you've got a 1 in every one of these columns, right? The way binary works is kind of the opposite. Think of it as the opposite of your odometer on your car. Okay, so let's say this is your odometer, and we'll do the, again, just make it so it's easy to see. You've got obviously more digits in this, but on your odometer, you just bought a new car and you're watching the odometer go up. Well, this figure here is the hundreds column, right? And this figure is a 0. And this is going up, and you start out with maybe 12 miles on it, and then you're driving a little bit, and you have 45 miles on it, and then later on you've got 76 miles on it. This column does not get activated until these columns get to 99. Okay, and then once this one is activated, these go back to 0. Right? And the same holds forth if you've got, you've got 999 miles on it, and you flip over to 1,000. And as soon as you flip over to 1,000, these all go to 0. Well, binary works in the same way, only in reverse. So let's pretend like you've got all ones except for the last column, 128. All right. This column doesn't get activated until all of these are turned on. And then when you increase by 1, this gets activated and all these become 0. So it's like the odometer, only in reverse. So imagine all these got to 9, and then you activated this one and it became the 1, and all those go back to 0. So if you've got only 1, these are all 0, so they're off. So this would basically be 128 because you've only got the one column, the one values column active. So let's go back to what we had before. So you've got everything active except for the last one. Okay. Now, just like the odometer, the hundreds column doesn't get activated until the other 2 are at 99. So if this one's active, it's 100. Well, before that was 1 less, was 99. So it's the same way. If you're 1 away from activating this and all these are active, you're at 127. So if you were to add this up and you've got 1, 2, 4, 8, 16, 32, 64, and I don't know why that threw that off like that, but if you've got all these active like that, and you add all these up, you're going to get 127. And you're more than welcome. You can pause the video and you can get your calculator out. You can check that. But that's what you're going to get. Okay? Delete that. So, that being said, if you've got all these active, okay, you can do this in 2 ways. You can either do it as I showed you before, where you're going to add up 1, 2, 4, 8, 16, 32, 64, 128, and you can add all these up, and you can get your answer. Now, I can tell you your answer, you can pause it and get the answer, but I'm going to show you the easiest way to do this, and it's exactly like we just got 127. if these are all active, and you already know that these values double each time, what's the next value after 128? The next column is going to be 256, right? Well, if that's 0, and these are all active, what's 1 less than 256? So you can either add all those up, or you can just do 256 minus 1, and that equals 255. That's the easiest way to do this. And again, we're human. We can make mistakes. So you've got two choices. You can either do 256 minus 1, or you can do 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And even if you're doing this on a calculator, you can still possibly make a mistake. Again, just like I said before, you can accidentally hit 9 on 8, you can hit 5 on 4, you can hit 5 on 8, and you might come out with, 254, or 256, or 248, or anything like that by fat fingering. It's going to be wrong. And you're going to get that answer wrong. And depending on the test, if there's only 10 questions, well, now you just got 10 points knocked off. If there's less than 10 questions, you just went from an A to a B on one question for something that, making I don't want to say a stupid mistake, because, it's a mistake. Again, we're human. It's something that's going to happen. But it's, again, I don't want to say stupid, but if you're gonna choose this path, there's more of a chance to make a mistake than just subtracting 1 from 256. Because you already know this value has to be 256. And if everything is on before it, then the number is going to be 1 less than that. And that's just something that, again, I wanted to, to throw out there, again, in case they toss something like that out there. And it's going to be the same way no matter what. If you've got, if they come to you and they say that the first 4 bits are 1, what is the next, what does that equal? Well, it's always going to be 1 less than the next column. So this is going to equal 15. So 4 and 8 is 12, plus 2 is 14, plus 1 is 15. It's always going to be 1 less than that. Same here. If they had all this, the answer is going to be 31. Now, if they had this, but say this was a 0, you can't. It doesn't work, because you don't have. They all have to be active before this one's going to become active. So that works along with anything. And like I said, I mean, even if you're all the way out here, and again, of course, it likes to not stay with my formatting here, but oops, change it back to 14. If they have ones all the way out, it doesn't matter. Like I said, if you can do 8, you can do anything. If they had this number right here, the answer to that is going to be 1023, because it's 1 less than the next value. It keeps doubling, and that's why I said if you could do an 8-bit, you can do anything. It's really that simple. So don't let anyone try to throw you off with all this, exponents of 47 times 32. It got crazy. I mean, it was to the point where, after the class, I was talking to some of the classmates, and I showed them how I do it, just like this, and they literally stared at me like they were waiting for the rest of the puzzle. And the one girl that I was talking to, she's like, "That's it?" And I was like, "Yeah, that's the answer." She's like, "Wow, I don't understand why, the instructor, the professor got so complex on this." So that's it. Hope that helps with any of your classes. Hopefully I'll get some more videos on this type of thing in the future with some Cisco stuff, access lists and all, which is something that's, again, something that they teach, make it seem a lot more complicated than it is. Thanks.